Let's start binary trees now. So in a binary tree, any node can have at most 2 children. That's why the name binary. So it can have 0 children, it can have 1 children, it can have 2 children, but not 3, not 4. So at maximum, any node can have 2 children. That's what a binary tree is. So what is a binary tree? A node can have 0, 1, or 2 children. Now, if you look at this, then this is a binary tree. Okay, this is a binary tree, and it has only one level. So what is a level? Before you understand level, you should know that what is a root. So any tree, for every tree is related with root, right? So for every tree, you will have one at the topmost, you will have a root, and then this root will have some children. Okay, it may have 2 children or it may have 1 children. Okay, if you just look at here, this is your root, this is your root, and this root has 2 children. This is your root, this root has only 1 children, and this, all of these 3 are binary trees only. Okay, in this tree there is only one node. In this tree you have a root and 2 leaves. What is a leaf? A leaf is a node that has no children, that has 0 children. That is called a leaf. Okay, and any other node which is not a leaf, that is which has a children, that is called internal node. Okay. Now, so what is the depth or level? Depth or level is of any node. The depth or level of any node is the number of edges from the root to that node. So the depth of this and this node, both of these nodes, depth is equal to 1. Okay. So what is depth of a node? What is depth or level of a node? Number of edges between the root and the edge and the node. Between the root and the node. Okay, so this is the depth of the node. Similarly, you have something called as height of the node. Depth and height. What is height of the node? So height of a node is from that node, what is the number of edges to the farthest leaf. Okay, so number of edges from the node to the farthest leaf. So one of my friends who did engineering in electronics and communication, but they had to study these binary trees. I don't know, maybe in the first year, I don't know when, but he told me that he was asked this question: what is the difference between the binary tree and the tree that you see in the world? And to which he replied, and I'm not saying that this is his original reply whatsoever, but to which this is what I heard for the first time, that he replied that what he said, the root of the tree is inside the ground, means the root of the tree is at the bottom. When you look at the world, the root is at the bottom, and the root of the tree in binary trees or in computer science, the root is at the top. So this is one of the, I don't know why I said this, but I will keep it. So even if you can see what is the height of the node, when we are talking about number of edges from the node to the farthest leaf. So let's say I take some bigger binary tree. Okay. Then if I ask you what is the height of this node, then you will see what is the long or farthest leaf from this node. Okay, this is also a leaf, this is also a leaf, this is also a leaf. Then you will go to the number, we will count the number of edges from this node to this leaf. Okay, so that is what your height of the node is. So you can see that, the farthest leaf is going to be at the highest level. Means to say that what is the depth of the node, means the farthest leaf will be at the highest depth, means at the most bottom, like, right? So yeah, you can, like I was talking about my friend, you can think about this. At the bottom you have leaf, but in real world at the top you have leaf. So at the bottom you have leaf, and the normally how do we measure our height? We measure our height from the ground. So this is my height. Similarly, what is the height of this node? So it will measure, we will measure this, the height of this node from the bottom of the tree, and which is the farthest leaf. So from the farthest leaf, what is the number of edges that you will count, and that is what the height of any node is. Okay. So what is the height of the leaf? Height of the leaf is 0, right? Height of leaf is 0. Height of the leaf is equal to 0. So height of this leaf is 0, height of this leaf is 0, height of this leaf is 0, because there is no path, because it itself is a leaf, means it has no children, so there is no going further down. Okay, so height is 0. Okay, for the leaf the height is 0, and for the depth, the root, the means the root of the tree is at depth 0. Okay, so every root is at depth 0, so depth of the root is 0. Now what is the height of the tree? Means this is the height of the node. Height of any node is the number of edges to the farthest leaf. So what is the height of the tree? Height of the tree is height of the node. Okay. Okay. And in a similar manner, what would be the depth or depth of the tree, or the level of the tree, or you can say maximum level of the tree? That will be the level of the farthest leaf, or the most farthest leaf from the root. Okay. Okay, so let's write down for every node their depth and height. So what is the depth? Depth is 0 and height is 0 in this case. Depth is also 0. This is your root, so its depth is 0, and this is also a leaf, height is 0. Here I'm not going to put d, and d is equal to, I am just writing an ordered pair. The first is depth and the second is height. So depth is 0. For every root the depth will be 0. For root the depth will be 0. And the height will be number of edges to the farthest leaf. So it is 1. Similarly here, what is the depth of it? The depth is 1 and the height is 0. So for leaf the height is 0 and depth is 1. Here it is 1, and here also it is 1 and 0 only. Now what is the height of this root? What is the height of the root? Is the number of edges to the farthest leaf, which is this leaf. So 1, 2, 3, 4, 5. Okay, this number of edges to the farthest leaf is nothing but the path to the farthest leaf. Okay, you know that we have already discussed what is path. So for what was this? It is at depth 1, right? And 1, 2, 3, 4. 1 and 4. What about this? It is at depth 1 and height 0. What about this? It is at depth 2 and height 1, 2, 3 and 1. So we will choose 3. What about this? It is at depth 1, 2, 3 and height 0. 1, 2, 3 and height 1, 2. 1, 2, 3, 4 and height is 1. What about this? 1, 2, 3, 4, 5 and height is 0. Okay. So of course it will be this will be reversed. The depth of the root is 0, right? The height of the farthest leaf is 0. The height of the root is 5. The depth of the root is depth to the farthest leaf is 5. And of course it has to be like that, because the depth, when you are measuring the depth of leaf, you are actually counting the edges in this path, okay, in the reverse path. And when you are calculating the height, you are only using these edges only, right? So that has to be like that. Okay, that's it for this video.